Welcome back to Beyond Binary, where we explore the technology shaping tomorrow's world today. If you've been following the tech world closely, you've probably heard whispers of a breakthrough that could redefine computing as we know it: photonic computing. It's the reason major tech giants, from Google and IBM to startups you've never heard of, are quietly pouring billions into research. But what exactly is it, and why are so many betting that light, yes light, will power the next computing revolution? Let's break it down. For over half a century, traditional computers have run on electrons traveling through tiny silicon pathways. These pathways, what we call transistors, have been shrinking at an incredible pace following Moore's law. But here's the problem: we're now approaching physical limits. Transistors can't shrink forever, and electrons, fast as they are, face resistance, heat buildup, and energy loss. In short, our current method of computing is running into a wall. This is where photonic computing comes in. Instead of using electrons, photonic computers use photons, particles of light, to carry and process information. And light has some remarkable advantages. Photons travel faster than electrons. They generate far less heat. They can carry more data at once because different wavelengths of light can transmit separate streams of information simultaneously, a concept known as wavelength division multiplexing. Imagine thousands of highways stacked on top of each other, each carrying a different set of cars, all moving at the speed of light. That's the kind of leap photonics promises. Now, this isn't science fiction, it's happening now. Researchers have already built photonic chips capable of performing AI calculations thousands of times faster than some of today's GPUs, all while using a fraction of the power. And this power efficiency is not just about saving energy bills, it's about making the impossible possible. Big tech sees the writing on the wall. Nvidia, the current king of AI hardware, is investing heavily in hybrid chips that blend photonics with traditional electronics. Intel has already demonstrated silicon photonic transceivers capable of transmitting terabits of data per second across data centers. And startups like Lightmatter and IR Labs are designing photonic processors specifically aimed at AI workloads. In fact, IR Labs has already partnered with the U.S. Department of Defense to build high-speed, low-latency communication systems powered entirely by light. But the promise of photonic computing isn't just speed, it's scalability. Traditional electronics require more and more energy as they scale up. Photonics, on the other hand, can transmit enormous amounts of data across vast distances without degradation. That means faster cloud computing, lightning-speed internet backbones, and data centers that don't overheat like nuclear reactors. Imagine streaming an 8K holographic video call across continents with virtually no lag. And here's a mind-bending fact: photonic systems can perform certain mathematical operations naturally, simply through the physics of how light waves interact. For example, multiplying matrices, a core function in AI algorithms, can be done by passing light through a network of optical components, with the interference patterns directly producing the result. No step-by-step electronic calculation needed. It's like the math just happens at the speed of light. Of course, this technology is not without challenges. Photonic chips still need to interface with electronic systems for storage, control, and certain types of logic. Manufacturing them at scale is tricky, as aligning optical components with nanometer precision is a huge engineering challenge. But history shows us that paradigm shifts often start with these very hurdles. Remember, there was a time when putting billions of transistors on a single chip sounded absurd. There was a time when fiber optic internet seemed overkill for the average household. And yet, here we are. If photonic computing delivers on its promise, we could see a new era of real-time, planet-scale computing. Global weather simulations accurate to the minute, AI-powered drug discovery that finds cures in days instead of years, autonomous systems that make instant decisions without the lag we experience today. In many ways, photonic computing is the natural successor to electronic computing, just as fiber optics replaced copper in communication networks. So, why is big tech betting on it? Because whoever cracks the code to scalable, affordable photonic processors will hold the keys to the next computing revolution. The transition won't happen overnight, but the seeds are planted and the momentum is building. In the next decade, you may not even know your devices are powered by light instead of electrons, but you'll feel the difference in speed, power, and capability. Here at Beyond Binary, we believe the shift to photonic computing will be one of the defining stories of the 21st century. So the next time you hear about a new AI breakthrough, a record-setting supercomputer, or a quantum leap in scientific research, don't be surprised if, behind the scenes, it's photons making the magic happen. Thanks for watching. If you found this fascinating, make sure to like, share, and subscribe. The future is bright, literally, and we'll be here to guide you through every beam of it.